Okay, we're going to be looking at systems of linear equations. So when we talk about a system, that's two or more lines, basically, that go together, or two or more equations that have the same set of variables. So basically, they both have an x and a y, in other words. And then when we're talking about a solution to the system, that's any ordered pair that satisfies all the equations in the systems. So the solution is any point that they have in common, so basically where they intersect. And so when we're looking at these, by far the easiest thing to do is if we can graph them. And so saying here we'll quickly graph the lines. Got x minus 2, so it's a negative 2, and there's a slope of 1. So that line will just go up like this, and the benefit of this is if you draw that line perfectly accurately, which I didn't quite get there, we got close, then we'll find that point where they intersect. So we'll put it 1, a slope of negative 2, so down 2 to the right 1, which really finds that solution for us right there. And I'm going to do my best to make sure it's as close to accurate as possible. And so graphing these, when we're graphing them by hand, got to work really hard to be accurate. So this solution would be 1, negative 1. But this is intersecting. So most of the ones we'll deal with will be intersecting. So they'll have different slopes. And these aren't quite perpendicular. They look kind of close. The important thing here is there's one solution. And that solution would be 1, negative 1. Okay, and so we'll talk about one solution, no solution, or infinite solutions is kind of how we're looking at it today. And so this next one, when I change this one, I'm moving the x over. So when I move this over to the other side, I get y equals 2x minus 4, or negative 2x. I got to change that sign. So from negative 4, go down 2 to the right 1. And I'll try to draw that as accurately as possible. Sorry about that. Okay, there we go. Got that line. Then the other one starts at positive 1 and has a slope of negative 2. So when we draw these, we end up with two parallel lines. And so these would be parallel. They have the same slope, which means there is no solution. So that's again our important part. This one is no solution. So if they're parallel or have the same slope, it's going to be no solution. And then we have on this one, if we move this over, I get negative 3y equals 9x plus 9. Divide by negative 3, and I get y equals negative 3x minus 3. And so that's going to be a line that looks like that, but what we should notice right away is that those two are actually the exact same line. So they call it a coincident system. And so not just the same slope, but this would be the same line. So we've got same everything, same slope, same y-intercept. And it would be, because I would draw the other line right on top of this one, then it would be infinite solutions. Okay, and so we're just looking today at, on this, is this, are these, how many solutions are there? So when I change it, this one would change to y equals, when I move the x, divide by y equals 1/2 x minus 1. So same slope, I'm going up here, since it's same slope, that means no solution. So no solution because we have the same slope and different y-intercepts. Okay, on the next one, we've got negative 2/3 plus 4, and just for time's sake, we should know how to change this around. We get y equals, for this one, negative 2/3 x plus 4. So these are exactly the same, and so when they're exactly the same, we'll say infinite solutions, and that's infinity sign, just a shorter way to write it. Which means for this one, when we change it around, we get y equals negative 3x plus 2. Different slopes, so we'll say one solution for that. And last thing it wants us to do is decide if a given point works as a solution for this. So it means that point would have to be on both lines. And so the way that we do this is we will take and plug it into both equations. And the nice thing about it is, if it works in both equations, then it's good. But if it doesn't work in one, then we don't have to worry about it. So let's try plugging this into the negative 2y equals 3 times negative 3. So I just plugged in negative 2 for the y value, negative 3 for the x value, and I get negative 2 equals negative 9, which is false. And so it doesn't match up to this line. So we don't even have to check the other one. We'll just say, no, it doesn't work. Okay, for the next one, 12(1), let's see. I'll plug it into, I'll plug it into the bottom one again. Got a 1 for y equals 1/3 times 12 minus 3. Divide that, I get 4 minus 3. And so 4 minus 3 does equal 1, so it works for that line. And for the next one, 1 equals negative 1/4 x, which is 12, plus 4. So 1/4 of 12, that would be negative 3 plus 4 equals 1. That works out. So we'd say yes, because that would be the point where both of those cross. And for the last one, you could graph it, you could plug this in. You should get an answer of yes, but that's one you can kind of try out for yourself and see how it works. So that gives you some information to start with on there. Mainly it's the recognizing if they cross, if it's parallel, or if it's actually the same line, and seeing what works for that.